Without further ado, let me introduce you our first speaker today, Jean-Philippe Seya from CrossBoundary Energy. He's the Senior Project Development Manager there, and he's specifically in charge of the large renewable energy project for its CNI customers. And it comes with a wealth of experience because previously he's been the engineering manager at Agreco for both Western and Central Africa. Honing his skills over the last 10 years. So really an interesting point of view with interesting case studies. And today, as I mentioned, he will be particularly focusing on telling us more about how to select the right technology for your specific needs with regards to Jean-Philippe. I'm very pleased to welcome you. If you can please turn on your video and your microphone. Yeah. There we go. Welcome, welcome.
Yeah, great. Thank you, John, for this great introduction. Hope everyone can hear and see properly.
Yes, we can hear you, we can see you, and you may share your screen and start your presentation whenever you're ready.
Okay, just give me a minute. I'm just sharing my screen. Good morning, everyone. Okay, so John, can you see my screen?
Yes, and you can just go in presentation mode now.
Perfect. Okay. Okay.
Perfect.
Okay. Perfect. I think you're set. Thanks for your patience. So yeah, good morning, everyone. It's a real pleasure for me to, to start that exciting time today. And thanks for the Solar Industry Association for creating this kind of exchange platform. Just a while ago, energy storage was branded as the new hot thing in the Silicon Valley. And now, less than a decade ago, the Silicon Valley Energy Storage Symposium was intended to showcase and monitor the progress and new developments of the solar industry, talking about pilot projects, new technologies, smart energy network of the future. And the good news is that now that future is here. We are living that future with some great improvements in terms of technology, in terms of progress and research and development in the solar and renewable fields. And that's an excellent and exciting time for us to be part of this industry. So I think John has clearly presented my background. I would like to emphasize the fact that I'm actually working for CrossBoundary Energy as a senior project development manager. So CrossBoundary Energy is basically a mission-driven investment firm that unlocks capital for sustainable growth and strong returns with a particular focus on the served markets in Africa and Asia and almost everywhere in the world. So we invest blended capital directly into mini-grid projects, CNI projects, to serve rural African households and businesses and allow entrepreneurs and the CNI sector to make savings while we are decarbonizing the industry in Africa. Okay, so just to deep dive into today's topic. So energy plays a crucial role, as we know, in our modern world, allowing us to capture and utilize excess of energy and mitigate the issue of intermittence of the renewable sources. So having heard a lot about the falling cost of energy storage solutions, many factories, many people, many managers are wondering how to take advantage of those new technologies to strengthen the power supply. So in this presentation today, we will explore various energy storage solutions and their benefits, The target is to better understand the various technology available in the market today, to share knowledge on the specific topic of battery energy storage system, since the storage system can be done using batteries or some other mechanical or chemical processes. But we will have a particular focus on the battery energy storage system, which is the technology of the era in terms of energy storage. And then the last part of the presentation will be focused on matching battery technologies and applications. We have a lot of technologies available in the market, and it can be overwhelming, but it's important for managers and developers to better understand which technology match with which specific application. Okay, so we'll start with a bit of history. We had several energy storage technologies used since since many decades, and the first technologies in the market was the gravity powered water, used mainly by the Greeks and the Romans a long time ago, really long time ago. And then we have moved from that water clogged storage system to the mechanical flywheel during the Industrial Revolution. And those mechanical flywheels were used to store rotational energy, and the applications were basically powering machinery during the Industrial Revolution time and regulating the speed of speed engines. And then we have moved around the 20th century to development of electrical energy storage technologies, and lead acid batteries became popular and widely used for stationary applications. Today, in our modern era, lithium-ion battery have emerged as basically the dominant solution, powering almost everything around us: portable devices, electrical vehicles, grid-scale applications, commercial and industrial applications. And that's today the most, let's say, popular storage system used worldwide. In addition to those ones, we have other innovative technologies such as the flow batteries, the compressed air energy storage, the thermal energy storage, and the conversion, hydrogen conversion, etc., which have also gained attention due to their unique capabilities. So that's where we are today. We have a lot of storage system available, and we really need to understand what do we need and what is the target we need to achieve. And then a storage system can play multiple roles. It can help to provide a transient response, or it can help to store energy. And depending on your needs, you need to know what direction to take and which technology to select. Okay, so let's focus on battery energy storage system. And the reason is simple. If you can see my screen, you will see how the price and size of lithium-ion batteries has evolved since 1992 till today. So in 1992, we were around 1.55 megawatt hour installed capacity, and the cost per kilowatt was roughly $6,000. And today, that graph has been done a couple of years ago, but if you can see the difference, we hit roughly $200 per kilowatt hour from the initial $6,000 20 years ago. So the price is dropping, and that is giving a huge opportunity for developers, industry, to provide a scalable solution for a wide range of applications, from residential, commercial, up to the scale, grid scale level. So benefits of the battery storage system includes high energy density, fast response time, and the capability to charge and discharge efficiently. So today, the challenge of the industries is to replace the thermal spinning reserve with the use of battery spinning reserve to reduce generators cycling, specific fuel consumptions. So in that regards, the battery system can be designed to provide a variety of services. So let's talk about the CNI sector based generally on thermal generation. So the battery storage system can replace the thermal spinning reserve and provide fuel savings by using less thermal capacity as the spinning reserve and shift it to the battery storage. The production in that case is minimal on the thermal side and maximal on the renewable side, and that's helped to better integrate the renewable energy, solar or wind, into the energy mix. So that's the first advantage and the first the first usage of the battery in that CNI space. The second one is to obviously, and that's a direct consequence of the first point, is to reduce the overall genset running time. If you burn less fuel and you are using less thermal generation for the spinning reserve, you allow to reduce the OPEX, I mean the maintenance frequency of your generator, and you are able to generate additional savings. And the last functionality of the battery system in the CNI space or in the grid utility scale is to smooth the loads and stabilize the network. So we know the challenge about the intermittency of the renewable sources. You can have a cloud which can disturb your solar production, and you can have any force majeure having a direct impact on your renewable production. And the battery system can, with the capability of charging and discharging rapidly, can supply additional loads for more power, frequency, and voltage systems. So you have a better quality of your energy generated from your renewable plants. So just to summarize, the battery system can play two major roles. The first one is to provide some kind of storage capability, which can be used to move from the thermal to the renewable spinning reserve, or you can provide some ancillary service like grid stability and power quality improvements. And we have a lot of technologies available in the market today, and we will go through maybe the most popular one. But we need to better understand the difference between the power capability and the storage capability. So as I've explained, the storage capability is the capability of the batteries to keep some of the power and deliver that power to ensure a kind of autonomy depending on how it's designed, while the power capability is the capacity of the battery storage to provide a certain amount of energy during a certain amount of time, to generally provide some ancillary service like grid stabilization, frequency regulations, and depending on how you want to use your system, you have a wide range of technology available. So I've provided a table to summarize what technology can achieve what services depending on a ranking on energy, power, life, and cost of the technology, basically. So if you take the example of the mining industry willing to increase the renewable penetration, what will be important is to focus on the energy capability of the technology, so the capacity of storing energy and providing a kind of autonomy, and the power capability as well, which means that anytime you have some sort of shortage on the generation plants, you should have the capability to ramp up rapidly and maintain the overall network stability. And for example, as I'm talking about, for example, a mining company, the best technology to achieve that, looking at the scale of that industry, maybe, for example, the lithium-ion technology, which offer a good energy and power capability. So from the and in addition, the versatile technology, that technology offer a very good performance while we are able to achieve an interesting cost of energy, actually, based on the recent research on the market. And we have some other technologies such as the sodium batteries, which are widely used for large scale storage. And we obviously have our old lead acid batteries, generally safe, inexpensive, but with a low cycle life and poor energy capabilities. So it's basically used for the power capability and the capacity to quickly ramp up and provide the necessary energy. And yeah, this is actually widely used in our standard vehicle, for example. So it's important to know which type of battery storage is available in the market and what can be the use and what your industry needs in terms of battery technology. So I would quickly move to the next one, and we'll have more time during the Q&A session to get back to some particular applications or more details on the technologies. But I would like to talk a little bit about the vanadium redox flow battery technologies. It's quite, it's not really a new technology, but it's well older than the lithium technology, but having a long track record than the lithium. One of the primary reasons for its slow adoption has been the lack of needs for long duration storage, as well as the lithium already develops and scale with quite an interesting cost of energy. So the vanadium redox flow battery are a type of rechargeable flow battery that offer unique advantages for energy storage. It uses vanadium ions, in different oxidation states to store and release electrical energy. So key features of this technology includes high scalability, since it can be easily scaled up or down to meet various energy storage requirements based on the configuration. We basically have a kind of electrolyte tank and battery cells, and you have, with that technology, a longer life cycle and a better scalability compared to even the lithium-ion battery. The decoupled power and energy provides the option to separate power and energy components, allowing independent scaling of power and energy capacity. And we have a quite rapid response time and enhanced safety. The only challenge we need to consider when we are looking at that type of technology is the logistics, because it's heavier than the standard lithium-ion batteries we are using in the renewable space. But this offers a very good storage capacity and scalability, as I've said, mainly for the utility grids applications. So that's part of the project, actually, in development stage, and it's progressing quickly compared to a few years ago. And it's something we need to understand, and it's a technology we need to be aware of. So I will conclude by saying that facilities that can successfully identify how battery storage system will save their business, will succeed in making significant savings and in leading the decarbonization industry in Africa. So the use of battery energy storage system is no more like 10 years ago a theory. It's a real advantage for the CNI space in Africa, and it's a real opportunity to do significant savings while we are reducing our carbon emissions and we are improving the way people are living and people are making money in Africa today. So I think it's important for us to better understand that the renewable energy and the battery storage and energy time is here, and we really need to take the opportunity to integrate those concepts in our daily activities as managers of CNI businesses. So thanks for your attention, and yeah, I will welcome the opportunity to answer some of the questions if time is allowed.
Thank you very much, Jean-Philippe. Very good overview. Always a difficult task to be the first to address the crowd, but I think you've done it amazingly well. And maybe for you, Vanadox storage is old, but I'm sure there's many people who may have heard about it for the first time, and I'm sure they will be investigating a bit further. I have a few quick questions for you. And from the crowd, wonder, like, based on your projects and on the clients that you work with, do you currently see customers that still have a reason or an advantage to continue working with diesel generators, or is that time already passed where actually all the clients you assist, you recommend them to go full with chemical storage?
Okay, yeah, that's a very good question. So I think that's purely a management decision, first of all, because renewable energy and storage need a leadership. But on the technical and economical point of view today, we have the opportunity with the use of renewables and battery storage to completely, not completely replace, but significantly reduce the use of diesel generators. We will reach that point where we have a cost of battery storage which allow to provide enough capacity to completely remove the diesel generators, but we need a couple of years to be able to achieve that target, looking at the cost of the system, at the capex we need to invest. But definitely in terms of functionality, in terms of transient response, and even quality of power supply, you can easily increase at the maximum, let's say at the maximum, the use of battery and renewable to replace the diesel storage. And depending on your type of loads, I think going zero genset on is actually possible, and we are doing it on some of our projects. It's a bit complex depending on the type of load you have to supply, but it's 100% possible, and that's where we are ending up. So in the future, in the very near future, and actually it's done on some of the industries, you can have the capability without degrading your quality of power supply to completely remove the diesel generators and provide 100% renewable system with solar and battery technologies.
In the end, I imagine it's very often a case-by-case basis, and as you mentioned, like highly dependent on the load profile of the customer. And a more tricky question for you, just to give an idea to the listeners, what are what is the range of savings that customers can expect at the moment? Because the price of storage is evolving quickly, the technology is evolving quickly. What are you seeing in the, without sharing confidential information, of course, but what potential savings are we talking about?
Okay, so it's quite a tricky question because it depends on the costs of the fuel, it depends on the duration of the projects, and it can depend as well of the type of usage you have to do with the bus system. So basically, when you are using your bus capacity for additional ancillary service, it's difficult to estimate. But if you want to use the bus system for purely storage, meaning that you are displacing the thermal spinning reserve to the battery storage spinning reserve, you can easily hit minimum 10% savings to maybe 50% depending on the how we are, I mean, integrating your solar and battery storage. But if you consider even the 10% saving on a lifetime of, I mean, 10% saving compared to the thermal energy bill, it's a huge and a significant saving in terms of financial returns. And in addition, what is not accounted in your question maybe is the emission saving, because you are saving in terms of emissions as well, which is valuable for sustainable developments of your industry.
Well, thank you very much, Jean-Philippe, for this great introduction to the different storage technologies and applications. I'm sure there will be many more questions flowing in, and I invite all the listeners who may still have some questions for Jean-Philippe. You can still submit them. We will share them with all our speakers, so there will be a possibility for follow-up after those sessions. But we now have to move on to our first panel discussion. Jean-Philippe, thank you very much once again.